All right. We are MBM Electronics, and we are presenting our product, the EcoNexus.
My name is Marc Massalt. I'm the head of software.
I am Bradley Karr, head of hardware.
And I'm Merari Mejia, the head of electrical hardware.
So in terms of our design specifications, we wanted to use a stepper motor with a photoresistor attached to it to scan two different positions, inside and outside. And using those values, I'm going to turn on a light with a relay, depending on whether it was high enough. Um, we wanted to turn on a fan, depending on how hot it was in the room and depending on whether the user had set it to a certain temperature. We wanted to use a OLED display to be able to change a lot of things and have the user visualize things going on in the product.
So this is our electrical diagram. As you can see, it shows all of our components. We have a fan, a relay, a temperature sensor, our power supplies, another relay that connects to our lamp, and we have a motor driver with our stepper motor, a photoresistor connected to a resistor, an LED display, and a potentiometer. And then the next slide will go into detail. So this shows how we powered all our components. We had three sources of powers, our 3v3 from the Pico and our V-Bus, which provides 5 volts. And then we also use a wall plug, which is 120 volts. So the photoresistor, the temperature sensor, the bipolar motor driver, and the LED display were connected to the 3v3 pin from the Pico board. And then the 5 volts power the potentiometer, the relay for the lamp, the relay for the fan, and the bipolar motor. And everything was obviously connected to the ground for our Pico. This is a schematic of the photoresistor and how it connects to our Pico. We had to use a resistor to control a backward voltage and the ADC pin for our Pico to get ADC values and not DC values.
To go into detail on how some of the stuff works, the light components, we use a relay to control light, and later I'll go over how it also controls a fan. We also use a photoresistor module, KY018, which is attached to a stepper motor to scan the area. Some pseudocode is provided on how the relay works. And then, yeah, next slide. And then the photoresistor was placed into a housing so it could look more clean and be more presentable. There's two holes on the housing. One is where the stepper motor goes into, and then one is a hole for the wires to come out of. And then at the very front is where the actual stepper photoresistor is located. Then we did also have a small issue where the wires, since they were soldered, did have an issue where the wired leads kept breaking off if moved a little too much. And then as for the temperature controls, another relay was used to control a fan, as mentioned before, a KY001 temperature module, which is a 18B20 temperature sensor on board alongside a 10 kilo ohm resistor. Was used to actually get the temperature measurements and was connected to the Pico via a via the pin 4, and this specific module also required some custom drivers which we located online. And then as for the last bit of the design details, we used an OLED display to show the user what the current temperature that the temperature sensor was reading, alongside the rotary knob, which lets the user select what temperature the fan will kick on, and also shows if the fan and or light is actually active at the current time.
For the software is really split up in three different components. We have the temperature sensor and the fan. the photoresistor and the light, and then the OLED display. So as you can see on the right, there's the main part of this code is really the true statement. So initially it checks for the temperature. Then we have an if press is equal to 1 that has to do with the the knob. It will set the maximum temperature to whatever value is set on the potentiometer, and then it will reset the press to 0. Um, then we have a function that turns on the OLED screen that I will go into the detail about after this. A function that turns on the fan, and then something that checks the luminosity as well as activates the lamp. And it will do this every half a second. So the temperature sensor in the fan, really what it does is we have something that checks the temperature using the external um, temperature sensor. We check if this is above the set temperature, and if it is, first thing we do is check if the fan has been turned on or not. And then if it has been turned on, we will go through and um, ignore, because we don't want to constantly turn it on and on. So we will just keep it on. And we'll do this essentially every 30 seconds. And so it will recheck the status and then turn on whether or off, whether the fan is already on or off and the temperature is higher than the maximum temperature. The photoresistor and light. So there's two parts to this. We have one that checks whether the luminosity is above a certain value, and then we have something that rotates our stepper motor back and forth every certain amount of time, so that we can check the temperature or the luminosity inside and outside. The way that we do this, while also not interfering with other programs, is we want to essentially be at one side for approximately 3 seconds, and then the other side for 3 seconds, without stopping our entire program. So we had to make a counter that goes through the check light function every half a second, essentially. And once it hits the counter of 5, it will turn it one direction, and then it will keep going until the counter is equal to 10, and then go the other direction. And then once I hit the other direction, it will take the average of the two values, and depending on that value, we'll use the light activate function to actually turn on the light if the light has not already been turned on. Then next up is the OLED display. This really all it does is display the set temperature, so what we want to set the temperature to, and then the actual current temperature. It also will display whether or not the fans are turned on or not. And it actually does that at the start. It will check the status of the light, whether or not it's on or off, and then it will, at the end, you'll see it will actually say on or off on the screen itself, as well as the majority of this code, which is just positioning it on the OLED display so that it looks legible for the user. So project outcomes. We were successful in having the fan turn on and off depending on what the temperature is. We were able to move the stepper motor back and forth so we can measure the light outside and measure the luminosity inside, and depending on that value, turn the lamp on or off. We were also able to display the temperature and the temperature reading, the set temperature and the temperature reading, as well as the status of the lamp and the fan.
And as for possible improvements in the future, there's a few that we would actually like to make. One would be to solder everything together. We want to remove as much of the excess wires as possible that aren't necessary. Another is to improve the solder and housing for the photoresistor stepper motor. As I mentioned before, that part did have some issues where the wires kept breaking off over time. We also want to again clean up the wires, make the design a bit more compact, and then possibly redesign and reprint a new style of housing where maybe the stepper motor is also included rather than a separate module.
Throughout this process, we learned a couple things. We learned to collaborate with each other. So we had to work around each other's schedule and have good communication to be able to accomplish our deadlines and our goals. When we started the project, we worked together to find which components we wanted to use, and then we split up our work and came back together at the end to assemble it and bring our code into one coherent piece. We also learned to be resourceful and use the internet and the slides and what we've used in class to come up with our design electrically and software wise. And then we learned to apply all the mechatronics concepts that we have learned from lecture and lab. So for example, we had to know how to protect our Pico from the higher voltage sources that we use for the fan and the light. So we had to use the relays, and we had to keep in mind the tolerances that of power and current that the Pico would support.
And here are our references for this presentation.
Thanks for
Thank
listening.
you.
So we're MBM Electronics. He is Marc, I'm Bradley, this is Mariah. And our project is the personal environmental control unit. And so we designed it based on using the Raspberry Pi Pico. All the electronics are housed in this 3D printed housing with a knob in the front with a display. And everything else is wired up in the back.
So it consists of two components. There's a light component and then there's a fan component, and I'll talk about the fan. So essentially what it does is we have a temperature sensor right behind here that measures the temperature of the surroundings. And what we'll do is essentially measure this temperature over a period of time and see how it compares to our side temperature. And that can kind of be seen on the screen where you can see with the potentiometer right here, we can set the temperature to what we want. And the moment it gets above the set temperature, we can demonstrate it. So currently it's about 19.25 degrees Celsius, and if I put it to like 17, it's gonna turn on the fan. This one is it's a little slow, and this guy will turn on, and it will start cooling down the room.
There you go. Fans on
There you
now.
go. So now the fan is on and starting to cool. It really consists of two different components. So there's the potentiometer and temperature sensor, which then control the fan.
So the other component is the light sensor, and we use the photoresistor for that part, which we put on this stepper motor that rotates 180 degrees. So like if you were to put the motor on a window, it would take the light from the outside and the inside, and it would kind of calculate the average over a period of time. And then based on the light it reads, it will turn on this lamp. So right now we have a lot of light, so the lamp is off. And if it were to be dark, it would turn on the fan.
Unfortunately, the wire literally just broke on the photoresistor. The solder wasn't too good, so it's likely not going to turn on right now anymore.
So if you want to talk about how you plug in your relays and all that.
Oh, yeah. Okay, and then I guess for the last bit, if you want to come closer. So the light and the fan are controlled by these two relays. The fans are plugged in straight to the wall, and then the relays just bridge the connection to actually let them turn on. And then everything else is wired currently into a breadboard for the stepper motor and the light sensor, along with like a basic 5 volt and 3.3 volt rail, so we can power everything more conveniently. But obviously in the future we would like to just like plug in everything without a breadboard, but that's for a future project.
I have a question of what is that stepper motor for?
This is to turn the photo sensor around 180 degrees, so it can take light intensity from outside and inside and take the average. So it can, if it's say bright outside but not so bright inside, it can determine that the light show shouldn't be turned on. But if it's dark outside, dark inside, it'll turn the light on.
So one of the wires came out.
It broke. Wow, that's what I was talking about. Okay. If this was connected, this would still be working.
Detecting the light source, right?
Yeah.
Right, yeah. So the photoresistors are here.
Yeah.
Okay. Yeah, so what are the challenges in this project? Because I see that you have a lot of method for power interface, like using the relays.
So that wasn't actually too difficult. Again, as I said, we simply used the breadboard to get two separate power rails, and they're all linked to the same ground. They're all to the Pico. Outside of that, it was just figuring out how to power these guys, and two relays solve that issue pretty easily. Outside of that, the only other hard part was actually getting this rotary knob to work, because there's 5 wires coming off of it, 2 of them for 5 volt and ground, the rest are for sense, one of them's for a click button. But we had to actually found drivers for that online, so it would work with the Pico, just plugging it in. There's 2 wires here, and counts upwards, 2 lights here. The rotary works.
Yeah, so right here you can see the number will switch when you repeat it, and then when you're ready to set it to that press it.
So the click is to like confirm the change. There's a chance that.
And there's also a little like stats indication for the light is on. Another challenge was, so we wanted both systems to kind of run at the same time. So in software, we had to figure out how we could have pauses in the program without actually stopping the entire thing. So for example, this thing is timed to go in a different speed than say the temperature sensor is, and to get that all working, we had to integrate some like counters and stuff to have it essentially all work simultaneously, because we could see that like the initial part, we just have it wait for 3 seconds here, but then if you wanted to change the temperature on here, it would have to wait till this motor came around back to actually update and start sensing the temperature. So to have that all work at the same time, we had to go through and do like little counters in our programs and functions.
Yeah, very good. Yeah, you actually plan everything. Thank you. All right.
Thank you.
Thank you. Good job.